What does it take to turn plain paper into money on a scale of $100 billion?
Secure run starting. Copy.
Today, we're going inside a high-security banknote factory to see the full journal.
Inspection ready.
Proceed.
These facilities don't print cash for fun. They produce currency ordered and controlled by a central authority.
Order logged.
Maintain chain of custody.
Step 1 isn't ink, it's security. Layers of checks before anyone touches a single sheet.
Checkpoint clear. Proceed.
No loose items, strict access zones, and constant tracking of materials from start to finish.
All clear.
Logged.
It starts with design, portraits, borders, patterns, and tiny details that are hard to copy.
Edges look clean.
Send for review.
Those swirling lines aren't decoration. They're engineered to fight scanning and duplication.
Locked. Security features are planned early, so protection is built into the note, not added later.
Layer check.
Approved. Next come printing forms, precision-made tools that transfer microscopic detail onto every sheet.
Cylinder set. Verified.
Now the foundation, specialty banknote paper or polymer, produced to strict standards.
Steel intact. Log it.
This isn't regular office paper. It's designed for durability, handling, and secure printing.
Fiber check complete.
Approved.
Some security elements are inside the substrate itself, visible only when light passes through.
Backlight. Confirmed.
Others appear as threads or windows, features that are extremely difficult to recreate accurately.
Thread visible.
Document it.
Before printing begins, inks are tested for color accuracy, consistency, and how they behave on the substrate.
Color match. Log it.
Even small shifts in color can signal a problem, so quality control starts long before the press runs.
Delta's off.
Hold that. Welcome to the heart of the factory. Industrial presses built for speed, precision, and repeatability.
Line 1 steady. Copy.
Printing happens in stages. Each pass adds specific layers of art and security.
Stage 1 running.
Maintain spec.
Operators don't guess. Sensors track alignment, ink density, and sheet movement in real time.
Sensor stable. Keep it tight.
First layers often lay down complex backgrounds, fine patterns that show distortion when copied.
Background pass clean.
Good, keep rolling. First layers often lay down complex backgrounds, fine patterns that show distortion when copied.
Background pass clean.
Good, keep rolling.
Perfect alignment is critical. If layers don't register exactly, the entire sheet can be rejected.
Registration locked.
No drift.
Some inks change appearance with angle or light, helping the public verify authenticity quickly.
Shimmer checks out.
Then comes texture. Certain printing methods leave raised ink, but you can feel with your fingertips.
Texture is strong.
Approved.
This stage creates crisp portraits and strong edges, details that cheap printing can't match.
Edges are razor.
Clean.
Climate control matters. Humidity and temperature can change how ink sits on the sheet.
Conditions steady.
Now the sheet returns for more layers, each one planned like a recipe with zero room for improvisation.
Next pass ready. Stay on spec.
You'll often find micro details, so small they look like a line until you zoom in.
Looks right.
Log it.
Some features react under special light for machine checks and professional verification.
UV scan.
Perfect alignment is critical. If layers don't register exactly, the entire sheet can be rejected.
Registration locked.
No drift.
A single flaw can trigger rejection. At this scale, small errors become big money fast.
1 rejected.
Track it.
Spot check. Looks good.
Machines catch most issues, but trained eyes still do spot checks throughout the run.
Seal it. Log it.
Even waste is controlled. Scraps and rejected sheets are tracked so nothing disappears.
Got the ID.
Next, serial numbers. Unique IDs help track production and support authenticity checks.
Verified.
These aren't random stamps. They're applied precisely and verified like every other feature.
Cutting must be perfect. A tiny shift can ruin corners, borders, and alignment.
Once cut, stacks are formed automatically, counted, aligned, and prepared for final checks.
Count matches.
Batch to cutting. At this point, notes still live on large sheets, multiple bills on one page.
Corners clean.
Edges matter.
Clean cuts help machines count accurately and keep notes durable in circulation.
Corners clean.
Edges matter. Clean cuts help machines count accurately and keep notes durable in circulation.
Final pass. Finished notes go through another round of inspection because errors become public instantly.
Some checks are simple and fast. Feel, alignment, and consistency across a stack.
Feels right.
Rooted. Seal confirmed.
Anything that fails doesn't go somewhere else. It's removed from the system and destroyed under control.
All sealed.
Destruction prevents leaks and protects trust because currency only works if people believe in it.
Straps on.
Passing notes are bundled into standard counts, strapped, labeled, and logged.
Batch A17 confirmed.
Every bundle is traceable. Batch codes connect it back to time, machine, and inspection results.
Handoff count, good.
Bundles become bricks. Bricks become cases. Everything is counted at every handoff.
Authorized entry. Now it moves into secure storage, restricted zones with logging, surveillance, and strict procedures.
Logged. Closing.
This is the part people imagine, the vault. But the real power is the paperwork and controls.
Hold the line.
Audits are constant. If the numbers don't match, production stops until the issue is solved.
Seal verified. Load complete.
When it's time to ship, currency moves like a high-value asset. Sealed, tracked, and escorted.
Seal's on.
Cases are sealed, so any tampering becomes obvious before they reach their destination.
Approaching the center.
Most shipments go to cash centers, where notes are stored, issued, and distributed into the economy.
ATM batch ready.
From there, banks receive notes based on demand. ATMs, branches, businesses, and daily commerce.
This is where the factoring's work becomes real. Money in motion, changing hands millions of times.
Over time, notes wear out. Central systems remove damaged ones and replace them with new prints.
These are done.
Fit, unfit.
Machines sort notes by condition. The worst are destroyed, and fresh currency takes their place.
Adjust the run rate. And yes, production volume changes with demand, policy, and replacing old notes, not just printing more. So what does $100 billion mean here? That's face value, massive output, tightly controlled.
Counted, sealed.
Moving, pallet 3.
At this scale, the factory is less like a print shop and more like a precision manufacturing plant.
All green.
Design, materials, chemistry, machinery, and security teams all work together to protect one thing: trust.
For you and me, the easiest checks are simple. Feel the texture, tilt for effects, hold it to light.
Yeah, that's it. Doesn't match.
Counterfeits usually fail at consistency. Colors, sharpness, texture, and alignment don't match the real standard.
From blank substrate to sealed cases, the process is a chain, and every link is monitored.
All links logged.
Every step is designed so mistakes are caught early, traced instantly, and removed permanently.
Because money is more than paper. It's a promise, backed by systems that don't allow shortcuts.
Feels different now.
Next time you hold a note, remember, you're holding design, engineering, and security in your hand.
Security, design, substrate, ink, printing, inspection, numbering, cutting, bundling, vault, distribution, all tracked.